Okay, I have the demo running. It's EEG. I will talk to which model? Which model should we talk to? Yeah, we don't really need to explain the screen. We don't need the model to look at the screen, so that's fine. We don't need the model to look at the screen. So it won't be Gemini. Let's do perplexity or something. Okay, so can you tell me one sentence about recording brainwaves, EEG, and what the EEG stands for?
Sure, EEG stands for electroencephalography, and it records brain waves by detecting electrical activity in the brain through sensors on the scalp.
So is it magnetic or electric?
EEG measures electrical activity, not magnetic. It picks up tiny electrical signals from the brain's neurons firing.
Okay, where this where's that electrical signal coming from?
The electrical signals measured by EEG come from the synchronized activity of neurons in the brain, especially from the cerebral cortex near the scalp.
Why is the cerebral cortex special? Isn't the neural activity everywhere in the brain?
You're right, neural activity happens everywhere in the brain, but the cerebral cortex is closest to the EEG electrodes, making its electrical signals easier to measure on the surface.
How do we say? Wait a sec. Did you say on the surface? How do we know where the neural electrical activity is actually coming from?
Good question. EEG, we
Good
know where.
question. Yeah, it's okay. You don't have to give me feedback.
Understood. I'll keep it simple. Let me know if you need anything else.
Yeah. So how do we know where the electrical activity in the brain is actually coming from?
We figure out where the electrical activity is coming from by using multiple EEG electrodes placed on different parts of the scalp. Comparing the timing and strength of signals helps estimate the source within the brain.
Okay, and where would the electrodes normally be located?
EEG electrodes are usually placed across the scalp in a standard pattern, often called the 10-20 system, covering areas like the frontal, temporal, parietal, and occipital regions.
Okay, and how about this is only, are we only talking about surface electrodes?
Yes, typically we're talking about surface electrodes placed on the scalp. There are also invasive methods, like intracranial electrodes, used in special medical cases.
Intracranial?
Yes, intracranial electrodes are placed inside the skull, directly on or in the brain tissue, often for very precise measurements in epilepsy or brain surgery cases.
How about have locations?
Besides the scalp, surface electrodes can also be placed on the face or neck to measure related muscle or nerve activity, but brain activity is mainly captured from the scalp or intracranially.
So say if you're looking at the cross section of the head, where else can EEG be recorded from?
In a cross-section of the head, EEG is primarily recorded from the scalp surface. Beyond the scalp, deeper recordings would involve intracranial electrodes placed on the brain surface or within brain tissue.
Okay, so can you actually go to bionicchaos.com/eegsynth? It's EEGSYNTH, and explain how is it relevant to what we are talking about?
I can't visit or browse specific websites directly, but I can help explain. The page likely explains EEG methods or technology, which relates to how electrical activity from the brain is recorded and analyzed.
Can you try browsing to bionichaos.com again?
I'm not able to browse directly to a website, but I can help by finding relevant information about EEG from trusted sources. Would you like me to search for details related to EEG methods or advancements?
Can you actually check out recoverix.com? So it's RECOVERIX.com.
The RecoverX system combines EEG with brain-computer interface technology to help patients regain motor function, particularly after stroke or multiple sclerosis. It detects brain signals for intended movements and uses functional electrical stimulation to trigger real muscle actions, effectively linking brain activity to physical movement.
Okay, and can you check out bionichaos.com? Tell me how it's relevant. It's BioniChaos.com.
BioniChaos.com is a platform focused on biomedical data analysis, particularly for EEG, ECG, and related tools. It offers interactive simulations and open-source projects that help users understand neural and cardiovascular data. It's relevant because it provides tools and visualizations for EEG data processing, aligning with the topics we've discussed about brain signal monitoring and neurotechnology.
Okay, and how is it relevant to recoverix.com?
BioniChaos.com and RecoverX.com are related in that they both deal with neurotechnology and biomedical data, particularly related to EEG. RecoverX focuses on neurorehabilitation using brain-computer interfaces and EEG for stroke or multiple sclerosis patients. BioniChaos offers open-source tools for EEG data analysis, which could complement RecoverX's clinical applications. They share a focus on making complex neural data more accessible for research, therapy, and education.
Okay, can we go back to where EEG can be recorded from?
EEG, or electroencephalography, is recorded from electrodes placed on the scalp. These electrodes detect electrical activity generated by neurons firing in the brain. This technique is non-invasive, meaning it doesn't require surgery, and it's widely used for monitoring brain activity in various fields, including neurorehabilitation, epilepsy research, and brain-computer interfaces.
Can you talk about the signal quality?
Sure, EEG signal quality depends on factors like electrode placement, sensor type, and interference. High-quality recordings use medical-grade electrodes and good contact with the scalp to reduce noise and improve signal clarity.
Okay, and how else could you improve the signal to noise ratio?
Improving the signal-to-noise ratio can be done by using high-quality amplifiers, reducing muscle and environmental noise, and applying filtering techniques. Proper skin preparation and the use of active electrodes can also further enhance the clarity of the EEG signal.
What's active electrodes?
Active electrodes have built-in amplifiers right at the electrode site. They boost the signal directly on the scalp, reducing noise from cables and environmental interference. This leads to clearer EEG readings, especially in mobile or high-movement environments.
Okay, and how about the position of the electrodes, the electrode placement?
Electrode placement follows standard systems like the 10-20 system, ensuring consistent positioning over specific brain regions. Accurate placement improves the ability to capture relevant brain activity and minimizes signal contamination from non-target areas.
Okay, and the depth?
Electrodes sit on the scalp, so they primarily capture cortical or surface brain activity. To get signals from deeper brain structures, more advanced methods like intracranial electrodes or special imaging techniques are needed.
Hey, can we go into those?
Sure, intracranial electrodes are implanted directly on or in the brain, offering extremely high-resolution signals from deeper structures. They're often used in epilepsy surgery planning or deep brain research, but they require surgery and are more invasive than scalp EEG.
Okay, and what's between intracranial and the surface?
In between, there are electrocorticography or ECOG electrodes, which are placed directly on the surface of the brain under the skull. They offer much higher resolution than scalp EEG and can detect deeper brain signals with less noise, but they're still less invasive than fully penetrating electrodes.
Okay, so we have fully penetrating deep brain recordings, intracranial. Then we have ECOG, electrocorticography, so that's on surface of the brain. And then we have surface, which is outside the brain. But do we have anything else? What else is there?
Yes, there are also minimally invasive options like subdermal electrodes, placed just under the skin, offering a middle ground. There are also newer techniques like near-infrared spectroscopy, FNIRS, which measures blood flow and oxygenation changes from
Okay,
the
we're
surface.
not talking about the FNIRS for now. Tell me more about the subdermal electrodes, and do they have any other name?
Subdermal electrodes, also known as subcutaneous electrodes, are placed just under the skin. They provide better signal quality than surface electrodes by reducing noise from hair and skin impedance. They're often used in research, epilepsy monitoring, and some BCI applications, offering a middle ground between non-invasive and fully invasive techniques.
Okay, so you mentioned subcutaneous electrodes, also the subdermal electrodes. What's the difference, and is there another term that can be used?
Subdermal and subcutaneous electrodes refer to the same thing, placed just under the skin. Another term sometimes used is percutaneous electrodes. The main difference is in placement depth. Subdermal is just beneath the skin, while intracranial electrodes go deeper into or onto the brain surface.
Okay, so we have subdermal, subcutaneous, uh, and
We
pericutaneous, whatever. How about subscalp?
Yes, subscalp electrodes are placed just beneath the scalp, deeper than subdermal but not penetrating the skull. They offer a stronger signal-to-noise ratio and are less invasive than intracranial electrodes, making them useful for certain monitoring applications.
So would it be called subscalp or periscalp?
It's typically called subscalp. Periscalp is rarely used. Subscalp is the more common term for electrodes placed under the scalp but above the skull.
But
This
is periscalp, is the term periscalp correct?
periscalp isn't a standard term. The commonly recognized term is subscalp. That's the most accurate and widely used name in medical and
What's
research.
the difference?
The main difference is in depth and invasiveness. Subscalp electrodes are placed beneath the scalp but above the skull, while intracranial electrodes, like ECOG, are placed directly on the brain surface or even inside brain tissue. This affects signal quality, surgical complexity, and the level of
No, but
invasiveness.
is there a difference between subscalp and periscalp?
Subscalp is the correct term. Periscalp is not a standard term in this context. Subscalp electrodes sit just beneath the scalp, above the skull, providing a minimally invasive option.
No, I meant periscalp.
Understood. Periscalp is not a widely used
Not
term.
periscalp, periscalp, as in SKULL.
Ah, I see what you mean. Periskull is not a commonly used term in the field. The recognized term is subscalp, which refers to electrodes placed
But
under
is
the...
it correct? Does it make any sense? I didn't say what's the most common. Does it make any sense?
I see what you're asking. Periscalp isn't a standard term in neurophysiology, and it doesn't commonly appear in literature. The proper and widely accepted term is subscalp, referring to electrodes placed beneath the scalp layer.
I meant periscalp. SCULL.
I understand now. Periskull isn't an established term in neurophysiology. The term subscalp is the accurate and recognized term for a... Glad we... Sounds good. If you want to explore more about subscalp electrodes...
Come on. You are... Okay, let's move on. Let's stop this one for a sec. You know, that says thread saved in history, but I don't actually... I don't actually see it. It is in the history. Yeah, if you have. Okay, which AI should we talk to next? Which AI should we talk to next? Let's see. Okay, let's move on. Let's move on. Yeah, so perplexity. Yeah, I can do okay, then it gets stuck. We're actually splitting hair on terminology. But we do wanna... Wait, can I actually continue the same conversation? No, we cannot go back to the voice model, which is interesting. Okay, and if we want to turn this conversation, like the placement of electrodes for recording EEG, we want to turn it into an interactive web application. How would you go about it? And how would it look like? Let's send that. Yeah, we don't have the voice anymore. I'm not gonna read it. Can pop it into another model. EEG placement. Yeah, EEG electrode placement something. A 3D head. That will be hard. Scalp, subscalp, ECOG, depth. A toggle recording modality. A 1020 high density. ECOG grids, strips. Place electrodes interactively on the head. I don't know if it will work. Yeah, it's going for the architecture of the thing. Yeah, we don't really care for it. React, TypeScript, whatever, WebGL. Optional 2D canvases. That would actually be more useful. It will make things clearer if we have a coronal, sagittal, axial link to the 3D view. As used in clinical intracranial EEG tools. The link open source interactive 3D web-based visualization. I heard about it before, don't remember what it is. Right, it's actually running because there is a URL for it. It's back from 2017. It's using Blend for web. Vision to construct. I only see one image of it. Yeah, I don't particularly like that the interface we can do better. Show hemisphere, left, right. Well, I mean, it's a 3D model, so we can show them both. Show contacts, monopolars, bipolars. Cortical region, random colors, or transparent. Why is it random colors? Isn't there some sort of color coding for them? Yeah, there's annotation, MRICT fusion, a yeah, we have a brain model. It's not about the brain though. Well, I mean, it is about the brain, but do we need like skull and skin? Is there a model that has a skull on top? 3D model. A backend, static JSON describing. Yep, we don't need a backend for this. Hopefully we can just do everything vanilla. A key concept, 3D head with transparent layers. Can fade in and out. Skin, scalp, brain, surface. So that brain visualization thingy. It's that model. It's the American Epilepsy Society. Can you just like download it? No. And eventually we'll have to ask the bot to actually do the web application. Wait, wasn't there an option for a canvas? Oh, that was a ChatGPT thing on the website. Wait, we already have a model downloaded. Better use it. I'm still looking for the tool because we had a 3D model of the brain. I don't remember the name for it. We did use it twice. We used it for this as well, for the TMS, the transcranial magnetic stimulation. Yeah, this tool should be a way of rotating the brain. Did I lose any frames when loading the tool? No. Well, that's good because we had another one where I think it's loading more of the brain. This one's only the surface. I can see some. Oh, here it is. Yeah, so it's only loading some of the 3D structures. How do you rotate this thing? Yeah, because it's when you move your mouse over it, it's actually moving the coils, which is, well, kind of fine. Ooh, except sometimes you're also able to rotate the brain. I'm not quite sure. Yeah, you can start your stimulation. Why the stimulation going as if it's going the other way? Let me going into the brain. But it looks like the stimulation is going outward. Yeah, you can choose a circular coil, TMS coil, or a 8 shape. No, just want to use that brain model in another tool. It looks like eyes. Looks like glasses on a human brain. Well, no, it's a transcranial magnetic stimulation coil. Okay, there's nonsense. Yeah, we're looking for another There's another tool, something with epilepsy. I forgot the thumbnail. Should remember what the thumbnail looked like. They should have had, yeah, seizure zone. Yeah, this one. This one might make my machine a bit slow because I think it's loading more of the brain. You can see, yeah, it's loading more parts, more 3D components, as opposed to this one that's loading only 3 or 4 something. You can see it in the 200 megabytes in the browser, and this one also 200 megabytes. Okay, but it did load a bit slow. I don't know why. Anyway, that model, hopefully for the two tools we don't copy the thing twice. Hopefully we just have the model sitting in one place somewhere on the server. Yeah, eventually by the sound of it we'll have to pay for Copilot or Code Assist, Gemini. I mean, we were using it yesterday. It did not time us out. Yeah, so each one of those is a separate 3D component of the brain. It is labeled, so we have the name for it and what it does in the model. I think. So we can use it. Just have to find where it's stored. Where's that model stored? I wish I remembered. Well, that's what we have an agent for. The agent should be just able to do all this stuff. Should be able. Yeah, we used up all the quota for Copilot. So now we're stuck with Gemini, which also not sure which model is it using. Because yesterday we were trying to fix something and it didn't actually work. It didn't actually work. Yeah, so the original idea was to have another tool that will show you different electrode placements around the brain for recording EEG, brainwave activity. We can mock something up, or just go ahead and use the model that we have. Yeah, so that's called seizure zone. Let's check where is the model actually stored. Seizure zone. Having too much things on the website. Way too many things. Someone's still in development. Static. Semiology. Okay, we have the JSON file for semiology. Well, there's 2 copies of it. We have the names for the brain parts. This weird looking thumbnail. But where is the model? Um, um, that's weird. Is it loading it from the web? I thought they're locally stored somewhere. Should be local. Okay, I might need more time to sort this out. Might need more time to sort this out. I don't quite understand where the model of the brain is being stored. All right, now I see it. It's called PL districts. It's the name of someone's name. Yeah, so we do have it locally. We do have it locally. We do have it locally, and we want to use it in another project. And we want to use it in another project. The model is only stored for in the folder for this project. And I'm not sure if there's an explanation for how to use the model, because it's a lot of files. It's essentially all the 3D components for the different parts of the brain. Different components for the different parts of the brain. They're all in object files. Object files. Obviously, there's no point loading any of it. There is no point loading any of it. They are object files. I just want to use them for now project. Wait, so the transcranial magnetic stimulation model using the same brain model. But then is there like a copy of it, or that's called TMS? TMS. So we have seizure zone, we have TMS. We'll get there eventually. It will be painful. It will be painful. Yeah, we have a copy of that model, so that's not ideal. How big is it anyway? I mean, maybe it's a good thing that we keep it a standalone, the project file. On the other hand, we should just have static. We do have a static folder for the whole website, so it should really just be over there, because now with the new web application we'll be using it 3 times. Where is our static folder? Yeah, we do have one. Yeah, this is where our EEG data is located. Yeah, we're using it multiple times as well. We are using it multiple times as well. Okay, we'll take a quick break and start again in a sec. I have a rotating brain for you. We'll have a rotating brain for you. And I'll come back in a sec. Can put some music or something. Oh, we haven't tried AI test kitchen music effects. That's right. And no, there was another version of it. There was this. But you need to be signed in. Why? Yeah, there's a music effects and music effects DJ. So we'll use the DJ. Road singing, hyperpop, vapor wave. Okay, I'll give it a go. Gets a bit annoying. Just leave the throat singing for now. Yeah, the DJ is hallucinating a bit. Yeah, that's the kind of stuff. I don't know if it's copyrighted or not. It's from UPenn, I think. From some paper, I don't care. We'll show it anyway. For the sake of science. Yeah, it was done open source interactive 3D. Well, it's open source, so we can show it. A 3D web-based visualization for intracranial electroencephalography, EEG. Yes, so that's the kind of stuff we want as well. So we want essentially to take one of those models that we have. I think it's a different model for the brain, also open source. And we want to put being able to place electrodes, EEG electrodes on top of it, and show where the locations are. Then the question really, we should also be able to simulate signals. So we can do something basic like where we add more or less noise, because yeah, the more external you go, the outer towards the surface you go, the more noise you'll be getting. Yeah, and then so we could have like a slider for, I don't know, each electrode or all of the electrodes if they are a deep brain or surface, and or anywhere in between. Yeah, so we're placing the electrodes and then we decide the depth of each. So in this case, I don't think it's possible in this case. Those are, I mean, I think the circles there are depth electrodes, and the discs are surface electrodes. I mean, surface of the brain electrodes, not surface of the head. So those will be ECOG of some sort arrangement. Supposedly it's a real patient. Montage electrode placement. So we are live streaming all the development process of everything we do. We're making this biomedical data science web applications, interactive web applications. They eventually all go onto our website, so you can see some of the examples. If you're watching the stream right now, this is an example of a simulation of a transcranial magnetic stimulation. You can place your coils on the head, on the brain, and it will try and show you what the effect of the stimulation will do, the strength of the stimulation, things like that. Then we have the seizure zone. Yeah, this one is actually quite advanced. It looks pretty simple. Where yes, there's a model of the brain. The model is hyper realistic. This model has like hundreds of different brain areas. And in this case, it will show you in a seizure situation, depending on the symptoms, which part of the brain will be affected. So for example, if you're having visual hallucinations and fear, it will show you which part of the brain is being affected by that red color of the coloring of that specific area, and it will also give you a blurb. It's called semiology or something, like a description of what's happening. The patient reports seeing visual hallucination and sudden onset of fear, possibly implicating the occipital lobe and amygdala, which are involved in visual processing and emotional processes respectively. So yeah, so it's highlighting these two regions of the brain. And you have a list of these things, like deja vu, lips making movements, visual hallucination, fear, muscle stiffening, and arm jerking. It's hard to show because it doesn't fit the screen really well. What else we've got? Auditory hallucination and head turning. I don't know why they are combined, but okay. Sudden loss of vision and numbness. And yeah, then you have a description for it as well. Patient reports sudden loss of vision in one eye. So that will be the contralateral side of the brain. The other side of the brain will be affected, depending on which eye it is. Followed by numbness in one side of the body, possibly implicating the occipital lobe for vision loss and the parietal lobe for sensory disturbance. So that will be called a semiology. By the way, they're not from papers and stuff. Those were generated by, I think, ChatGPT or something. Difficulty in speech production. So that will be the speech area over there. Potentially indicating involvement of the frontal lobe, particularly Broca's areas, which includes the pars opercularis and pars triangularis. Yeah, the coordination and balance, so on and so forth. So that's just an example of the things that we can do, the things we do. Yes, if you're having any questions, especially if you're watching the stream, do let me know. Pop them in the chat so I don't forget. Yes, we're trying to use this same model. For choosing placement of the electrode. So it will be somehow similar to this tool here somehow. Yeah, so unfortunately, we'll have to continue next time. Yeah, so the idea of it was using this brain model. In this case, we're using it for modeling TMS simulation. In this case, semiology of brain activity or symptoms during seizures or in general symptoms. But then we want to also use it for electrode placement on the head. Yeah, we'll have some rough idea and we'll turn it into an interactive web application next time. So yeah, and everything we do is available on BioniChaos.com. Go check it out. Provide your feedback. And I'll see you next time. Yeah, check out the Biomedical, the heart rate monitoring. So this one extracting heart rate from your webcam. I think it can do it even if your face is blurry. Might need more color saturation. Yeah, I mean the signal is there. Contrast. Yeah, I think the blurriness should not make it better or worse, but a contrast, brightness, a color saturation, white balancing. Yeah, signal is there. The 63 is probably what I'm experiencing right now. Yeah, I need more like natural light to increase the signal quality. But yeah, check it out. Provide your feedback. I'll see you next time. Bye.